Okay, so welcome to day number 2 of the AI and using also Chat GPT. Yesterday, I didn't record it actually, but I came to several conclusions. Now, before I want to explain this, how the AI works, and assume just you are complete beginners, maybe this will help you to understand a little bit more. So, assuming that we have a pretty simple neuron network with 5 features, which would mean, let's say, 1 minute price candle, let's say 3 minute candle, maybe volume, maybe some other features, I don't know, RSI for example, and I don't know, current price, let's say. Just sorry, it's paint, and I'm and keep it fast forward. So we have some input data. They could be 5, 10, 500, whatever, and we have some in between layers with neurons. So what it means is basically, let's assume connections are with yellow. That the first neuron has an entire overview of all the inputs. We should not assume this is how it works. And all these rest of the neurons in TensorFlow, they also have, let's say, neuron number 2 also has all the connections between them. The neural network basically starts learning by inputting random weight values. So what it means is that this neuron at a random learning process could see that there's really less impact of 1 minute price candle, but there is more impact to RSI and 3 minute or maybe volume. So the first neuron has like some kind of weight balances between all those inputs, which is basically a mathematical formula. Let's say it really depends on the neural network setup, but you could say this is less important, this has a value of 1, 0.5, this has a more important value of 1, this is most important, it has a value of 3, this is less important, it has a value, for example, of 2, and this is not important, this has a value of 0. So what it means is, of course, when you when the system is trading, all values mean something. And the problem number 1 is that this value should never be 0. So talking with ChatGPT yesterday, the thing is, what could happen eventually is we have like a ton of, let's say we have 100 features, like parameters, market analyst data, that we want to analyze the market and learn the model. Now we have only 5, but let's say we have let's say 1,000 inputs. So all of them definitely have some kind of impact. We don't know how much, but most of them have some kind of impact. So what we should avoid getting values of 0. So we still need some values of 0.1. So what happens is not make the neuron die, not make the value itself die. So I'm not saying that I'm a complete professional in this field, but there is a logic to it, especially when you know what do you want the AI system to learn. So knowing the trading as I know it, as automation as I know it today, from many years of experience, I would tell the neural network to not think that some values don't have value. For example, also some values can have a zero impact, like a zero value, and this could also impact the output. In fact, especially when you're considering this, that a neuron could be, after all those calculations, a neuron could have an output. Let's say this neuron has an output of 0 to 1. But what are we actually thinking about is it's really less values there. So what it means is it could have like 0.1, like a step could be 0.1. But if we allow the neuron to be from -1 to 1, then we have twice more detail in one neuron. And then when we use like an activation function like sigmoid or some other functions, we have a little bit more steps in the calculation. So meaning that we have a little more space in actually determining the quality of these inputs. So basically, if RSI indicator oscillates from 0 to 100, maybe 0.01 could be enough. But if it's a value like, let's say, Bitcoin price that starts with 4,000 and ends with 100,000, there's lots of details in between. So maybe you consider adding more steps, so changing the activation function. So I changed it to Swiss, like a Swiss cheese. But what it is, it's more predefined in deep learning networks, avoiding dead neurons. So what it actually means, what it means is I try to add the model 100, 200, 300, many layers, and I still get out the prediction ratio accuracy of 0.6124 precisely. And no matter how I change the layouts, I still get the exact configuration. I'm using around 3 million data points. So the thing is, what I noticed is that at some cases, maybe the AI figures out that we don't need this neuron, we don't need this neuron, we don't need this neuron. We are completely sufficient. Let's say this indicator, and this sums out the value, and we already have the correct answer, so we don't need all of these anymore. So just because these neurons die out, because they end up turning values of 0. So keeping in mind that when you are developing these systems, that there is a high chance that such a thing, I'm not talking even about overfitting, I'm talking about the model itself, that the configuration between activation functions and learning methods can lead out to not actually fully utilizing all indicators or futures or price, whatever you want to set up. So in my opinion, I'm starting to think we need to change this model to something more interesting, something really interesting. Maybe we can get out some really nice data points. So at one point I thought, I don't know how to realize this, but at one point I thought, how about we have, let's say, sorry, I'm not familiar with this program. We have, like, let's say 3 neurons, 1, 2, 3. So then the system figures out which of these neurons are most important. Let's say it figures out and gives out like an answer, which would be the market most definitely will rise or will fall. Well, let's say there's an answer that the neural network gave. But what if we receive the answer and combine it again? I will not draw it in this sketch, but what if we combine it again with those inputs, meaning that we have another connections with each neurons. Let's say it would in art it would look like this. Then we have again and then the last one. So how would this look if we were to draw it? So the neural network learns and points out, okay, the market will definitely go up. This is the first neural network output. And then we have the answer of the price go up, and we still have raw data input features, and let the neuron decide. Okay, we decided from these previous indicators the price will go up, features I mean, and now we have again clean raw data and already pre-learned recommendation the price will go up. Can this affect the result? So what it does, it could eventually tell, okay, we have the price goes up, but the artificial intelligence itself, the learning process itself, could even develop that, hey, we now see this recommendation together with this recommendation is more valuable. It gives us like a more valuable details. So I thought maybe such an architecture could help improve the results. Yeah, and then I thought what I want to test also is even which one is what? Okay, anyway, even if we have those inputs and those neurons in between, what if we sum up additional markets? For example, Litecoins, Ethereum, or Ethereum BTC, and we put together 3 additional markets, add much more neurons. Let's say we have more dense layers in between, and we use softmax to providing multiple answers. Let's say some 10 answers, maybe 13 answers. So this would be a 1% rise for Ethereum. This would be 1% drop for Ethereum. This would be 2% rise for Ethereum. This would be minus 2% rise of Ethereum. And this would be, let's say, 5% rise for Ethereum. So what it means is we have much more inputs and much more outputs, and determining the outputs, what I think is we could eliminate even more dead neuron system, and by means we could also have like a summarized, more detailed output. Let's say you use one large neural network, that all of those neurons does something, and all of those neurons could see something more than just a single yes or no answer, the rise or fall. So by adding complicity, we could maybe add also quality to it. So such tests I figured could maybe work out even better. But if a problem cannot be solved in a simple way, but it could not be solved in a difficult way. But what I think is that in such a way we could utilize the neural network much more, adding details much more, like features much more. And what we could also achieve is a more useful prediction that comes out. For example, okay, he's telling us that the price will go up 1%, it's a 70% prediction, but the price will go up 2%, it's a 80% prediction, something like this. So you have a more overview. Okay, he sees that this is a short-term rebound or short-term pump, let's say for 2, 3, 4% only. I will go in for a 0.5% target or something. So maybe it could not only achieve such goals, but it could also give some more insights and utilize the neural network itself much more. So that's what I thought to try out in the next videos.